Questions 21 through 25 on the 2017 Grade 8 Gauss Math Contest. The number of dots on opposite faces of a regular die add to 7. 4 regular die are arranged as shown. Which of the following could be the sum of the number of dots hidden between the dice? All right, so let's talk about this. So we've got to look at that sort of part, and that part. There's going to be a number on the bottom and a number on the top. So the number on the bottom of this die and a number on the top of that die, and so on. Okay, so I'll call this 1, 2, and 3, and we'll talk about each one. Okay, so let's talk about 1. I've got a number on the top and bottom. At the bottom of the first die, that number, and I've got a number on the top of the second die. So we've got to figure out what those numbers are. Well, the number on the bottom of the first die, that's easy. It's basically 7 minus 3, because the numbers have to add up to 7. So 7 minus 3, and that's 4. Okay, so we got that one pretty quickly. Now the number on the top of the second die, that is not as obvious, but we know that we've got a 6 and a 4. So we have a 6, so the other side, the opposite side, will be a 1, since those two numbers have to add up to 7. And then we have a 4, so the number on the opposite side has got to be a 3, since those have to add up to 7. So the two that we don't have so far are 2 and 5. Correct? So that means that the top is going to be either 2 or 5. So I'll just say it's 2. And then the 5 would obviously have to be the bottom. And that's what we are going to talk about here. This section that I've labeled 2. That we've got the bottom of the second die, which we have already established as 5. And then we've got the top of the third die. Okay, let's talk about that. So now we're talking about this guy right here. Okay, well, we have a 3 that is being shown to us. So that means the other side has got to be a 4, since those add up to 7. We are also being shown a 5, so that means the other side is a 2. And then that means we have two numbers remaining, 1 and 6, right? So I'll just put 1 as the top, and therefore the 6 will be the bottom. And that brings us to talking about region 3, where we're going to have the bottom of the third die, which we have already established as a 6, and the top of the fourth and final die. Okay, that one we have to talk about. Well, we are given 2 and 4, so that means we've got 2 and 5. Those will be those 2. And then we have a 4, so it'll be a 4 and 3. And then the only ones that we haven't established are 1 and 6. So 1 could be either at the top, or 6 could be either at the top. I'm not sure, right? We don't know 100% which one is going to be at the top, but it's going to be definitely either 1 or 6. Okay, well, it looks like, let's put that 4 in red to be consistent. These are the numbers. So let's see what kind of sums we get. First, let's use 1 as my choice for the final one. And when I add those up, I've got 6, 11, 12, 18, and 19. So my sum is 19. And then when I choose 6, my sum will be 6, 11, 12, 24. So the sum is either 19 or 24 of the dots that are hidden in between those dice. And of the answer choices, the only one is 24. So, number 21, the answer is C. The values 2, 3, 4, and 5 are each assigned to exactly one of the letters V, W, X, and Y to give Y to the power of X minus W to the power of V, the greatest possible value. The value of X plus V is. Okay, so we've got to make that to have the greatest possible value. That is going to be done if we make this the greatest and this the smallest. So let's concentrate first on making this the biggest I possibly can with these four numbers, and I can only use one number once each. Well, I'm pretty confident that 5 and 4, or 4 and 5, those are the two ways to make this number as big as possible. Let's see. 5 to the power of 4 is 625. 4 to the power of 5 is 1024. So obviously, I'm going to use this one. So I'm confident that 4 to the power of 5 is the biggest number I can make y to the power of x. Now we're going to concentrate on w to the power of v. I've only got 2 and 3 left because I can only use each number once. So that means either it's 2 to the power of 3 or 3 to the power of 2. This is 8 and this is 9. And remember, I've got to make this as small as possible. So that would be this choice. So 2 to the power of 3. And therefore that's 1024 minus 8, which is 1016. Now they're interested in x plus v. My x is 5. My v is 3. So x plus v is 5 plus 3, and that is equal to 8. So number 22, the answer is D. Mike and Elaine play a game in which each player is equally likely to win. The first player to win 3 games becomes the champion, and no further games are played. If Mike has won the first game, what is the probability that Mike becomes the champion? There's only 3 games, right? The first to win 3 games, actually. Okay, so we have a few scenarios. The first scenario is that Mike and Elaine play only 3 games, and Mike wins all 3. So Mike wins all 3. The other scenario with Mike and Elaine is that there's 4 games in total that they play, but Mike wins 3. Obviously, he has to win 3, but Elaine wins one game. The other scenario is Mike and Elaine play 5 games, but then the distribution for Mike and Elaine is 3 and 2. And these are the only ones that are possible, because if you have, let's say, 6 games and Mike and Elaine both win 3, that's not going to work, because as soon as Elaine wins 3, he becomes a champion, or as soon as Mike wins 3, he becomes a champion, and no further games are played, as they state in the question. So this is the only 3 scenarios. So this is scenario 1, scenario 2, and scenario 3. So let's talk about all 3. The first one, Mike wins all 3. The probability of him winning a game is equal. So apparently that's a half, right? So if he has 3 wins, it's going to be a half for the first game, a half for the second game, a half for the third game. So that probability is 1 over 8. But here's the thing. They have already told you that he won the first game. So that is already established. Mike has won the first game. So we have to act as if that is not part of the probability. That's already been established. Now, from that point forward is what we have to calculate. So very important distinction. So Mike already won game 1, G1. So now, if he's going to win all 3, he has to win 2 more. He has to win the second game, probability of a half. He has to win the third game, probability of a half. That is a quarter. That is the correct way of figuring out that probability. Now we get to scenario number 2. Mike wins 3, Elaine wins 1. So it can happen as follows. Mike wins game 1. Mike wins game 2. Elaine wins game 3. Mike wins game 4. Or Mike is already established as winning game 1, but Elaine could win game 2. Mike wins game 3. Mike wins game 4. And these 2 are the only scenarios. Okay, let's figure out the probability of each of these. Well, each of these, we don't calculate the first one because that's established. We just concentrate on the next 3. Well, the probability of this happening is a half, this happening is a half, this happening is a half. So when you combine them, you multiply them all. 1/2 times 1/2 times 1/2, that would be 1/8. Same thing over here. Probability of this is a half, this is a half, this is a half. When you combine them, it's 1/8. So this 1/8 plus this 1/8, we have to add them. And when you do, you get 2/8, which is a quarter again. So we have this quarter, and we have this quarter. Now we calculate the probability of scenario 3. Scenario 3 has 5 games, and Mike wins 2 and Elaine wins 1. So we have a few different ways of doing it. Mike always wins game 1, and then Mike also will win game 5 because he has the game, the whole entire tournament, whatever you want to call it, ends when Mike wins his 3rd game. So he can either win the 2nd game, the 3rd game, or the 4th game. And then Elaine would win the other games in between. So these are the scenarios. In this one, it would be G2 and G4 for Elaine. And in the last one, it would be G2 and G3. And Mike, of course, wins game 5. All right, let's calculate the probability for each of these. Remember, that's fixed, so we don't worry about that. We only worry about these guys. This is a half, this is a half, this is a half, this is a half. So you multiply them, a half times a half times a half times a half, and that would be 1/16. So this would be 1/16. And in a very similar way, this is going to be 1/16, and this is going to be 1/16. So you add them all up, 1/16 plus 1/16 plus 1/16, and that is, of course, 3/16. So now to get the total, we have to take this 1/4, add it to this, to add it to that. 1/4 plus 1/4 plus 3/16, and that grand total is 11/16. And that, 11/16, is choice C for number 23. In the diagram, ABC is a quarter of a circle with radius 8. A semicircle with diameter AB is drawn as shown. A second semicircle with diameter BC is also drawn. The area of the shaded region is closest to. This diagram is at the heart of the question, so let's concentrate on it. The first thing I'm going to do is draw a line from B all the way through to cut that shape in half. And when you do, things will start to come into focus. Then I'm going to label each of these sections a certain letter. So this section I'll just call A, and by symmetry that's also going to be A. This section I will call B, and by symmetry that will be B. And this section that is not shaded will be C, and by symmetry that is also C. Now let's talk about any kind of relationship. Well, the first thing, of course, is I've noticed that this is a semicircle, and that semicircle, in terms of my lettering, is 2b plus c. The area of a semicircle is pi r squared divided by 2. So 2b plus c is pi r squared divided by 2. R in this case, well, the diameter is 8, so radius would be 4. So it would be pi 4 squared over 2. And therefore, 2b plus c is 8 pi. So that is my first equation. Another equation is all the letters, everything. 2a plus 2b plus 2c equal pi r squared divided by 4, because that's a quarter of a circle. In this case, the radius is from there to there, so that's 8. So it would be pi times 8 squared divided by 4, and that is 2a plus 2b plus 2c. And then 8 squared is 64. 64 divided by 4 is 16. So that means this is 16 pi. And then we can divide through by 2. And when you do, you get a plus b plus c is equal to 8 pi. Now I want to concentrate on this section right here. So let's draw in a couple lines. A line from there to meet perpendicular, and this line right here. So this is perpendicular right here. Now let's talk about this. This shape is basically a quarter of a circle. And what I want to really concentrate on is B. This B right here. That B. That B basically can be represented as follows. The area of that quarter circle, so pi r squared divided by 4, minus this triangle. That triangle would basically be what you would subtract. And since this is 8, this is going to be 4, the radius of that semicircle. And very similarly, the distance from there to there is also the radius, so that's also 4. So the area of that triangle, and since this is a right angle, can be easily calculated with 1/2 base times height, where the base is 4 and the height is 4. So there we go, B, therefore, and then this R in there is 4, right? Because it's half of the diameter. So this becomes pi times 4 squared over 4, and this is 16 over 2. So B will basically be 4 pi minus 8. Okay, so now let's try to get decimal values for everything, because in the end they want us to approximate. So when I take out my calculator and put 3.14 for pi and calculate this, this comes out to 4.56 for B. And now I will take this equation and substitute in 4.56. So 2 times 4.56 plus C is equal to 8 pi. Pi is 3.14 approximately, and when I do that calculation, that mathematics, I get 16. And then finally, I can now use that to figure out A. A plus B plus C, well, B is 4.56, C is 16, and 8 pi. 8 pi is 25.12 if you use 3.14, and this calculates to 4.56. So what were we asked to find out in this question? The area of the shaded region. Well, according to my labeling, the area of the shaded region is 2A plus 2B. Well, A is 4.56, and B was also 4.56. Okay, interesting. And then when you do that math, you get 18.24. Therefore, is closest to, if you look at the answer choices, D for number 24. Brady is stacking 600 plates in a single stack. Each plate is colored black, gold, or red. Any black plates are always stacked below any gold plates, which are always stacked below any red plates. The total number of black plates is always a multiple of 2. Total number of gold plates is always a multiple of 3, and the total number of red plates is always a multiple of 6. For example, the plates could be stacked with 180 black plates below 300 gold plates below 120 red plates, or 450 black plates below 150 red plates, or 600 gold plates. In how many different ways could Brady stack the plates? The black plates are always a multiple of 2, so let's say 2n. The gold plates are a multiple of 3, so we will call them 3k. And then the red plates are a multiple of 6, so we'll call them 6m. Now notice I chose different letters because they are not necessarily the same letters. So now what we have to do is try to figure out all the different combinations. So let's begin. The first scenario, black, gold, and red, is when you have all the plates of the same color. So 0, 0, 600. 0, 600, 0, 0, 0, 600. So that's pretty straightforward to figure out. And as you can clearly see, there's 3 such ways of doing that. The next scenario or type of scenarios is when you have 0 plates of one color. So either 0 red or 0 gold or 0 black. And then we have to figure out how many are there of the other colors. The first scenario, when we have 0 red, that is going to be an equation that we have to work with. We only have black and gold, so that means 2n plus 3k is equal to 600, right? Because that is what we have to represent the numbers b, g, and r. Now, what we have to do essentially is figure out integer solutions for that equation. And we begin, and remember, in this table, I'm actually going to be putting in values for n and k because I'm looking at that equation. So here we go. Quickly figure out that n cannot be 0 because n has to be a number. N equals 0 in that scenario, but we're not dealing with that anymore. If it equals 1 or if it equals 2, we don't get an integer value for k. But when n equals 3, we do. We get 198. Okay, so this is going to be 0 all the way down. The next integer value that works for n and k are 6 and 196. And then you just keep going like that in a very predictable way. You just keep going, and you can find that the end of the road is 297 and 2. So now we have to figure out how many were there. Well, if you divide this by 3, you get 1, 2, all the way to 99. And that quickly tells you that there's 99 of those. All right. So in the very same way, we're going to approach the next one. This time g is 0. So we have 2n plus 6m this time is equal to 600. Okay, well, 0 all the way down there. So now let's start with red equal to 1. And again, where I'm putting in values for n and m here. If m is 1, then I get for n 297. If m is 2, I get 294. And in a very predictable way, you just keep filling out those. And you find out that the end of the road is 99 and 3. So how many did we get? Well, it's pretty easy to count this one. That's 99. All right, so now you're getting the hang of it. 3k plus 6m this time is equal to 600. Same thing, trying to get integer solutions. When you put in 1, you get 198 here. This is going to be 0 all the way down. When you get 2, you get 196 here. And then you just keep going like that. And the end of the road in this table is 3 and 99. Very easy to count. How many? 99. So there we go. So those ones are done. Now we get to a scenario where we have some of all 3 colors. There's no zeros anymore. So I've got to figure out B, G, and R. All right, so if I put in 1, I quickly figure out that it's not going to work. Why? Because my equation is 2n plus 3k plus 6m is equal to 600. And that equation gives no integer solutions for n, k, and m when n is equal to 1. All right, let's try n equals 2. Again, it doesn't give me solutions, but when I get n equal to 3, I start to get integer solutions. And that means I've got to take into consideration that now n is fixed as 3. So this becomes 6 plus 3k plus 6m is equal to 600. And that means 594 is equal to 3k plus 6m, but I'm going to factor out a 3 to give k plus 2m, and then therefore k plus 2m is 594 divided by 3. And that is 198. All right, so now I've got to figure out integer solutions for this. And that's not that hard. When you start playing around with that, you figure out when k is equal to 2. That's how you get the first integer solution. It's 98. When it's 4, you get 97. And ... You just keep going like that. And at the end of the road, you get 196 and 1. So what we quickly figured out is this took care of the 3's. And as you can clearly see, there's 98 of them. All right. So you keep going like this, and I'll do a few more so that you can get the hang of it. Let's now go to 4. when b is 4, we don't get anything. When b is 5, we don't get any integer solutions. But when b is, when n is 6, you start to get integer solutions. So what are those integer solutions? Well, this 2n would become 12 plus 3k plus 6m is equal to 600. So that means 3, and let's factor it out, k plus 2m is going to be 588, correct? And then now we divide through by 3, and you get k plus 2m is equal to 196. So now we have to figure out integer solutions for this with n fixed as 6. And that's not too big of a problem. We know that k is not going to give you anything when it's 1, but when it's 2, you start getting integer values. And that first one is 97. When it's 4, it gives you 96. And then you just keep going. And at the end of the road, you get 194 and 1. So as you can clearly see, that gives you 97. And then you just keep going down like that. Dot, dot, dot. Right? And then at the very end, as you can see, the values for n, 3, 6, they're going up by. When you keep going, you get to 297 for n. So when n is 297, it becomes 2 times 297 plus 3k plus 6m is equal to 600. So this is, factor out the 3k plus 2m, and then 2 times 297 is 594. 600 minus 594 is equal to 6. K plus 2m is going to be therefore 2. So the only solution for here is going to be 1 and 1. All right, so that gives me only one solution. So what I think, what makes the most sense to me is that all of these guys look like 1, and then there was probably 2, and then 3, and then 4, and so on, 9, all the way up until 97, 98. So we have to add all these up now. All right, so when we add them all up, we had 3 here. We have 99 here, 99 here, 99 there. So 3 times 99. And then we had from here 1. And then like I have sort of deduced, 2 plus 3 plus 4, dot, 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 all the way up until this 97. And then that 98. Okay, so this is 3 plus 297, and using the formula n times n plus 1 over 2 to add consecutive numbers, that can be 98 times 99 divided by 2. So that looks like 300, and then 98 times 99 divided by 2 is 4851. So, and when you add it to 300, it becomes 5151. And that's it. So, challenging question. The answer to number 25, 5151, that is choice E.